Hello there, today we'll be doing LRU cache. Let's check it out. In this particular problem, we are given a data structure that we need to develop. It's called the least recently used cache. And we're going to try to get our least. So basically, we have a container, let's say 2 in this case, of 2 size. Capacity is of size 2. And what happens is that once we fill up this container past 2, let's say we put a 1 in, and a 2 in, and a 3 in, we gotta remove the 1. If we access the 2, then it moves here. And if we add another thing in, then we will need to remove the 3 instead. So in that way, we remove the least recently used item. And we're gonna put that towards the head of our list. And then all the new items are going to come in from the tail. One thing to note is that we can't use a array to do this head and tail business, because if, let's say, we have more items than 2, let's say we have 4 items, and let's say we need to move this item. So we need to go in and find the 3, and then when we remove it, that's an O of n operation. That's moving all the items, even though finding it is O of 1. We need to move it to the n. So we can't do that. We need a different data structure because we need our runtime for get input to be O of 1. And this O of 1 is going to be of we need a linked list. So instead of this, we have a linked list. So we have a 4 that points to 2. Those are all the keys and values, so that we can access these things pretty quickly. So with that, we have a linked list that points to head and tail. And that way, when we have an item, we can just repoint the item. Let's say we remove 4. So let's say 4 is gone. Then that means these items now point to each other. Great. And we just need to add this to the end, and done. Yeah, perfect. And with that, we have the linked list is complete. And when we need to access it again, well, we put it in the correct place, and we can remove it when we need to remove it, and add it in when we need to add it in, and that does our get input properly. Now, to have pointers, we need pointers to these items. And this gives us a O of 1 lookup time. So we need a hash map that does the key to node. That way we can go straight from the key, look up the key, and go straight to our node where we keep our key and value, so that we can quickly return that value and move it around. Alright, with that, I think we have understood what we're trying to do here. And we're ready to write some code. So let's create a capacity equals capacity. We need a self.hashmap equals dictionary. We need a node. We need some nodes. So that means we need a class called node, and we need an init function. We can just shrink it a little bit. So even though it's not the perfect, we just need to be able to see it. And we need some keys and values. So self.key equals key. Self.value equals value. We should have a self.next equals none. And self.previous, previous node equals none. And that's our node. So let's get some self.head equals node of 0, and self.tail equals node.0. And let's point them to each other. So head is going to point next is equal to self.tail, and self.tail.previous is equal to self.head. So this is, let me show you the diagram immediately, what that shows. So we have a head, and we're going to point that to our tail. And our tail is going to point back its previous to the head. This is how we're going to start out. This way, all operations are exactly the same, whether it's the beginning or the end, because that way we have the tail pointer to help us guide us in adding items, and the head pointer to guide us in removing items, as well as the items that are at the end and the beginning are the same. The removal and the adding is the same because we just need to look for pointers that exist. Okay, so without getting into details, let's get the broad sense of what needs to be done in the get function first, and then we'll go into the details. So in a get function, we must see if it exists in a hash map. So if key in hash map, then let's do something. So when it's in the hash map, what we want to do is remove it from a location it's already in. So self, let's say remove, let's say the hash map at this particular key, the node to remove. So let's maybe we should make this easier for us to look at. So the node is equal to hash map key, and we're going to remove this node and add it back at the end, and we need to return the value. No, that value. Perfect. I think that's it. So otherwise, we return -1. Great. And then now with the get put function, what happens if the key is in the hash map? Well, what happens is that we need to remove it. So the reason is because we see it now again, and we don't know what's going to be. So with that, we removed it. Sorry, we don't remove node. We just remove it one time. So. Okay, so now we need to produce a new node. One thing to note is that this is key value, so that means I need actually to do that. Okay, so we have our key and value for our node. What's next is that we need to add this node to the end of our tail. So self.add node, and we need to add this set our hash map at this particular key equal to this node. And with that, we are done. And if our length of hash map is greater than our capacity, that means we need to start removing items. So self.remove the last item, the most recent item. So at the end of at the head. So remove node equals head dot next. So with that, let's remove node. I think it's better if we just call it node and node right here. And once we remove it, we need to remove that particular node from a hash map too. So hash delete hash map of this particular node dot key. Is there anything else I'm missing? I'm not sure. So I've removed it from our node, deleted it from our hash map. I think we're good. Yeah. If there's something missing, then I'll fix it later because I don't see anything else that's an issue right now. So yeah. Okay. Now let's define the add function and the remove function. So when we add, we get a node, and we need to remove this, add this item to our node. Let's say we need to add an item to this particular case here. Add it to this, and so we need to add it with the tail in mind. So tail.previous is going to be this item. So tail prev. So we need a tail prev equals tail.prev. That's the previous item, and the previous item is going to .next is going to be equal to our item, which is our node. So this now points to our node, of course. And this tail still points to our head. Okay, great. And so this node needs to point back at the tail.prev. And so now we have this picture here where it points to the head, tail.prev, and we need to point this back at the tail. And tail.prev is now equal to node, so it points it back to node. And I think that's good to go. We have put in a brand new node. Let's remove it. So delf remove self at node. So let's say we're trying to remove this node here. We have the node in question, and so we need the node.next, node.prev, and node next, because we need to join these two. So node prev needs to point over to node.next, and node.next needs to point back at prev. And that's it. So node prev equals node prev, node next equals node.next, node prev dot next is equal to node next, and node next dot prev is equal to node wait, what node dot next dot prev is node prev. Okay, wait, so node next prev is node prev. Makes sense. Okay, good. Node.prev.next, yeah, good. Now they point to each other and the middle is skipped. Great. With that, I think we're ready. Let's run the code and see what we're missing. Hash map. Hash map. Oh, this is trouble. Oh, shoot. Okay, well, here we go. Any more? That looks good, but I'm pretty sure we're missing something. Uh-oh. As you can see here, I'm not very skilled in writing out classes. Alright, looks like it's working. I hope it works. And it does! Oh my gosh! Okay, that's surprising. Okay, so what we have here is a pretty nice code that solves this particular problem in O of one time for put and O of one time for get, as we have shown in our example below. And yeah, I think the answer speaks for itself. I don't know if there's anything to add or to remove from this video. If you do know, please let me know what it is, and I will look into that. And let me just shrink this code a little bit, so it's gonna be a little bit cramped, but that way all the code's in one line. So maybe here, that way it looks a little bit better. Yeah, it's gonna have to, we'll have to lose this line, unfortunately. So that way we can get all the code in. It's gonna look a little, well, this doesn't have to be stuck together. Okay. And with that, we have completed this problem. If you enjoyed this video, like and subscribe. If you want more videos, check the link in the description below. Thank you very much, and I'll see you in the next one.